Hello, this is Casey Baja, an MD PhD student at the University of Illinois at Chicago College of Medicine. This video is part of our Survivors Advising Scientists educational program, a bidirectional educational platform meant to connect our communities and increase scientific literacy and engagement. Our goal is to bring everyone to the table for scientific discussions related to cancer, science, and therapies. This is video number 6, Statistical Significance. Researchers want to know if observed differences are true differences. Either they have measured a real difference, or even though it looks like they've measured a real difference, in reality, they've measured a difference that occurred by chance. Scientists generate p-values, usually using computers, to test if a difference between groups are significant. In other words, if the difference is big enough to be considered real. On the left-hand side, we have an example of an experiment that is statistically significant and shows a true difference. As you can see in the bar graph, the adult group has much more wisdom compared to the teenage group. If there is a difference, but it is not significant, we call it a trend. On the right-hand side is an example of this. You see in the bar graph that there is an interesting trend, but no difference between the groups. The adults compared to the teenagers seem to be eating more fruit per week, but the researchers note that this is not a significant difference. What is this p-value that indicates statistical significance? Even the best experiments have variability in their results. In the experiment on the left-hand side, we are measuring the number of Skittles that are counted as red. In this experiment, 5% of orange Skittles were accidentally measured as red. However, scientists can still be confident that orange Skittles are not red Skittles. If we assume orange Skittles are not red Skittles, the null hypothesis, the p-value is the probability that we will accidentally call an orange Skittle a red Skittle by chance. Mistakes or variability happen. You can accidentally call an orange Skittle a red Skittle. Usually, scientists say this variability can happen 5% of the time to be able to write it off as a chance event. This is where we get the p-value of 0.05. Let's review some more examples of different p-values. On the left-hand side, we have a p-value that equals 0.05. That means there is only a 5% chance that an orange Skittle will be called a red Skittle. On the right side, we have a p-value of 0.01. That means that there is only a 1% chance that an orange Skittle will be called a red Skittle. This is an even better result and statistically significant. Let's walk through an example that is statistically significant and has a p-value of less than 0.05. In this example, the treatment worked. Researchers are testing a drug's effect on tumor size. The null hypothesis is that the tumor size of the experimental treated patients equals the tumor size of the standard treated patients. The average tumor size of the treatment group, however, is much smaller than the tumors of the standard group. There is a less than 5% probability that any given tumor size measurement of the standard group will fall in the range of the treatment group by chance. Therefore, the difference cannot be explained by chance, and researchers must reject the null. This experiment is statistically significant, and any difference in measurements between the groups cannot be explained by chance. On the flip side, we have an example of an experiment that is not statistically significant, with a p-value of greater than 0.05, and there is no difference between the groups. In this example, the treatment did not work. The researchers are testing a drug's effect on tumor size. The null hypothesis, again, is that the tumor size of the experimental treated patients equals the tumor size of the standard treated patients. The average tumor size of the treatment group indeed is about the same size of the tumors of the standard group. There is a greater than 5% probability that any given tumor measurement of the standard group will fall within the range of the treatment group by chance. Therefore, any difference between the groups can be explained by chance, and researchers must fail to reject the null. When experiments are not statistically significant, any difference between the group can be explained by chance, and we see that there is no difference in the tumor sizes in this example. Differences can be significant even if the differences are small. As you can see here, the tumor size in the experimental treatment group is less than the tumor size of the standard treated group. There is a difference, and researchers are indicating that this difference, even though small, is statistically significant. The greater the size of the control and experimental groups, the greater the chance a small difference can be shown to be significant. For example, if there is a lot of patients enrolled in the study, this can help with the significance. Significance talks about how real the difference is between the groups and not how big the difference is. But do small differences matter? Even if there is a significant difference, patients may or may not care if the difference doesn't affect them in a positive way. In this example, the tumor size in the experimental treatment group is different than the tumor size of the standard treatment group. However, there may be some deterrence from using the experimental treatment, like an abundance of injections or toxic side effects that make it not clinically significant. Clinical significance talks about how much the difference benefits patients, whereas statistical significance only says how trustworthy a result is. Pro tip number 1. Usually an asterisk mark denotes statistical significance. Be on the lookout for a key in the figure text. More than one asterisk can be used for even smaller p-values. Pro tip number 2. Significance that demonstrates a correlation does not necessarily mean it demonstrates a causation. Often, additional experiments are needed to demonstrate a mechanism. In this module, we have discussed statistical significance and p-values in experiments. So when evaluating a result, you can ask the researchers these questions. Are the results significant? What is the p-value? What p-value are you using for significance? It usually can be 0.05 or 0.01. Is the p-value significant? Are the results clinically significant? This is the end of Module 6. Now the presenters would like to thank Dr. Kitayeski and the administrative staff of the University of Illinois Cancer Center for their support in this effort. Additionally, we'd like to give a special thank you to all the cancer patient advocates who provided feedback during the development of these modules. We'd also like to thank you for reviewing this module, and we invite you to send any feedback on this module or suggestions for future content. Please feel free to move on to the next module, number 7, on types of clinical studies. Thanks again.